Hi, everybody. It's Professor Mitchell. We're continuing Chapter 7 on decimals, percents, and real numbers. And today we're going to be talking about percents. We will talk about fractions, decimals, and percents as representations of rational numbers with conversions from one form to another, proportional relationships to solve percent problems, techniques to solve problems, including discounts, interest, compound interest, and percent increase and percent decrease. And finally, strategies for percent computation and estimation. So percents are special kinds of fractions, namely fractions with a denominator of 100. The word percent comes from the Latin phrase percentum, which means per hundred. So the definition of percent, n percent, is the same thing as n hundredths, where n is any non-negative number. So in this example, we'll write each of these decimals and fractions as percents. So to convert a number that is not a percent to a percent, the easiest way, I think, is to think about multiplying that number by 1, but think of the 1 as 100%. All right, so by multiplying each of these numbers by 100%, you're not changing the value of the number, you're just writing it in a different form. And as you know, when you multiply a number by 100, it just moves the decimal point 2 places to the right. So, and that may be the trick that you're familiar with for converting to percent, is just move the decimal point 2 places to the right. So for example, if I take 3 hundredths and I multiply it by 100%, I'm going to get 3%. Decimal point moved over here. Now, if I have the repeating decimal 0.3 bar, think of that as 0.333333, on and on forever. And if you move the decimal point 2 places to the right, that's just going to put a 33 in front of the repeating 3. So that'll give you 33.3 bar percent. All right, so another repeating decimal. 1.2 times 100% would give you 120%, right? And it does make sense in certain contexts for percentages to be more than 100, and we'll possibly look at some of those later. Here we have a very small decimal, and if I move the decimal point 2 places to the right, that's just going to give me 42 thousandths of 1%. Of course, 1 times 100% is just 100%. Now, when you get into fractions, there are a couple different ways you can think of this. If you multiply this fraction by 100%, you would get 300% divided by 5, which is 60%. The other way you could do it is change the fraction to a decimal. Either way, you will get 60%. 2/3 as a decimal is 0.6666666, repeating. So just like in letter B, if I multiply that by 100%, I'm going to get 66.6 repeating percent. And then finally 2 1/7. So one way you could do this is to change this to an improper fraction. It would be 15 sevenths. 15 sevenths times 100% would be 1500% divided by 7. And then by doing that long division, you would end up with 214 2/7%. So hopefully that's all review. And then going the other way, the way that I like to think of this is that, excuse me, 1% stands for 1/100th. So if you have something like 5%, you can think of that as 5 times 100th, which is 5 hundredths, and that would look like this. All right, and the shortcut trick that some people like is when you're changing a percent to a decimal, you move the decimal point 2 places to the left. By the way, this is not the way I teach it in my pre-algebra class because I'm always afraid that people are going to get mixed up. When do I move it to the right? When do I move it to the left? So I prefer to make it a percent, multiply by 100%, to take away the percent sign, replace it with the fraction 1/100th. All right, 6.3% would be 63 thousandths. 100% is 1. We saw that in the last example. 250%, if you multiply 250 times 1/100th, you get 250 divided by 100, which is 2.5. 2/3 of a percent, be careful with this one. 2/3 times 1/100th is 2/300. As a decimal, that would be 0.006 repeating, all right? And then 33 1/3%. 33 1/3 as an improper fraction is 100/3. 100/3 times 1/100th would be 1/3, and we already know that that's 0.3 repeating. Applications involving percent usually fall into one of the following forms: finding a percent of a number, finding what percent one number is of another, or finding a number when a percent of that number is known. So basically there are 3 pieces to a percent statement, and those pieces are the percent, the base, which is the number that we're taking a percent of, and the amount, which is the amount that's left when you take the percentage of your base. So what you're seeing in these 3 different problems is first unknown percent. No, I'm sorry. The first one is unknown amount. The second one is unknown percent. And the third one is unknown base. So for example, a house that sells for $92,000 requires a 20% down payment. What is the amount of the down payment? So this is probably the easiest type of problem. All right, we need to find 20% of 92,000. 20% of 92,000 is 20 hundredths times 92,000, which comes out to 18,400. And by the way, just to give you a little bit of preview of a mental math technique, easiest way to find 20% in your head, it's even easier than taking out your phone and doing the calculator. 10% would just be move the decimal point 1 place to the left. So 10% would be 9,200. And if you double that, you get 18,400. And that comes in handy. 20% is a common amount to tip in a restaurant, right? So it's really easy to figure out the tip in your head. You don't need a calculator. So the down payment is $18,400. Next example, if Alberto has 45 correct answers on an 80 question test, what percent of his answers are correct? So we need to find what percent of 80 is 45. So they've set this up as a proportion, which is one common way of solving percent problems. 45 is to 80 as the unknown percentage is to 100. And if we solve this equation for n, let's see. I don't really think I like the way they wrote this. Let me do something here, because if you cross multiply 45 over 80 times, if you cross multiply 45 over 80 equals n over 100, you would just end up with 45 times 100 equals 80n. You wouldn't have this part here, so I wouldn't write that. Okay, so it should just be 45 times 100. I think I see what they did. They started out with 45 times 100 equals 80n, And then they probably thought about dividing both sides by 80, but then they shouldn't have left the 80 over here. Anyway, the unknown percentage comes out to 56.25, which means that 56.25% of Alberto's answers are correct. All right, next we have 42% of the parents of the school children in the Paxson School District are employed at DePaloma University. If the number of parents employed by the university is 168, how many parents are in the school district? So this is an example of an unknown base problem. So the problem is 168 is 42% of what number, right? So we need to find a number such that 42% of that number is 168. So if we call that unknown number n, we get 42% of n is 168. And then changing that percentage to a decimal, we get 42 hundredths n equals 168, which means n is 168 divided by 42 hundredths, which comes out to 400. So there are 400 parents in the school district. Next example, if skis at a sports store near Humphreys Summit are on sale for $476 and the original price was $560, what percent were they discounted? So this is an example of an unknown percent problem. First, we need to figure out the dollar amount of the discount. So if the original price was $560 and the new price is $476, the amount of the discount is $84. And the discount is taken from the original price, so we need to find what percent $84 is of $560. So to do that, we can divide 84 by 560, which comes out to 15 hundredths. 15 hundredths, 15%. So the discount was 15%. One way of doing mental math with percents is to use fraction equivalents. So here are some percents and their fraction equivalents. You can use a known percent. So frequently we may not know a percent of something, but we know a close percent of it. This is kind of similar to what I was talking about earlier with the 20%. For example, to find 55% of 62, you could start by taking 50% of 62, which is easy. That's just half. So that would be 31. And then 5% would be 1/10 of 50%. So if 50% is 31, then 5% would be 3.1. And now you just add those two together. 31 plus 3.1 would be 34.1. Estimations with percents can be used to determine whether answers are reasonable. For example, if Laura wants to buy a blouse originally priced at $26.50, but is now on sale at 40% off, she has $17 in her wallet and wonders if she has enough cash to buy the blouse. How can she mentally figure this out? And we're going to ignore sales tax. In a lot of states, sales tax is not charged on clothing anyway. So instead of taking 40% of $26.50, we could take 40% of 25, which is take 10% of 25, which is $2.50, and then multiply it by 4. So 40% of 25 would be $10. So, and of course the actual discount is going to be more than that because the estimate is 40% of 25. 40% of 26.50 is going to be bigger than that. So this is actually a high estimate of what the blouse will cost, which is $16.50. So if she has $17 in her wallet, she definitely has enough money to buy the blouse. All right. So using the techniques that we were just talking about and a little bit of common sense, which of the following statements could be true and which are false? First one is Leonardo got a 10% raise at the end of his first year on the job and a 10% raise after another year. Good for him. True or false? His total raise was 20% of the original salary. Well, that is actually false because let's say, just to use nice round numbers, that his original salary was $100,000 a year. 10% of 100,000 would be 10,000, which would put his salary at the end of the first year at 110,000. So the 10% raise in the second year would be 11,000. So the total raise would be $21,000, which is not 20% of the original salary. It's actually 21%. So this is an example of compounding. Okay, so that statement is false. Next, we have Young and Dina paid 45% of their first department store bill of $620 and 48% of the second department store bill of $380. True or false? They paid 45% plus 48% equals 93% of the total bill of $1,000. Well, unfortunately, that is also false. Percentages don't add up that way. They do add up sometimes, but not in this case, because the 45% and the 48% are being taken of different amounts, okay? This would work if they, let's say the first month they paid 45% of the total bill, and then the second month they paid 48% of the total bill. But in this case, they did not pay 93% of the total bill. They unfortunately paid off much less than that. Okay, now compare that last one to this one. If Bill spent 25% of his salary on food and 40% on housing, then he spent 25 plus 40 equals 65% of his salary on food and housing. This statement is true because the 25% and the 40% are being taken of the same pot of money, okay? Unlike in the last example. Next, in a town, 65% of the adult population works in town, 25% works across the border, and 15% is unemployed. And everyone in town is in exactly one of these categories. Well, let's see, 65 plus 25 is 90, 90 plus 15 is 105. So it would not make sense to account for 105% of the population, so that must be false. So that's an example of where a percentage over 100 doesn't make sense. Here's an example where it does make sense. In Clean City, the fine for various polluting activities is a certain percentage of one's monthly income. The fine for smoking in a public place is 40%, for driving a polluted car is 50%, and for littering is 30%. Mr. Schmutz, oh, that's clever, committed all three polluting crimes in one day and paid a fine of 120% of his monthly income. Well, assuming that these numbers add up correctly, 40 plus 50 is 90, 90 plus 30 is 120. Yeah, it looks like Mr. Schmutz is on the hook for 120% of his monthly income. Hopefully, he's got some money saved up. All right, that brings us to interest. Suppose you borrow $6,000 from a bank at a simple interest rate of 5% to be paid off 2 years from now. The $6,000 represents the amount of the loan. The 5% represents the interest rate. And the period of the loan is the amount of time you owe the money, in this case for 2 years. Simple interest means that the interest will only be computed on the principal for the stated time of the loan. So that's as opposed to compound interest, which and that's the way that most credit cards work, unfortunately. So, you know, let's say that in the first month of having a credit card, you charge up $1,000. And then at the end of the month, the credit card company puts, let's say, $20 of interest, tax that onto your bill. The next month, let's say you didn't make a payment in the first month, they're going to charge you interest on $1,020. Okay, so the amount of interest will go up. That's compound interest. This is simple interest. They're only basing the interest on the principal. The formula to calculate simple interest is I equals PRT, where I represents the simple interest, P represents the principal, R represents the interest rate, and by the way, that interest rate has to be written as a decimal, and T represents the number of years. The formula for the total amount, A, to pay off a loan, is A equals P plus I, so principal plus interest. And remember, we just said that interest is P times R times T. So the total amount to pay off a loan is P plus PRT, which can also be written as P times 1. All right, so another example. Vera opened a savings account that pays simple interest at the rate of 5.25% per year. If she deposits $2,000 and makes no other deposits, find the interest and the final amount for 90 days. So interest equals principal times rate times time. The principal is $2,000. The interest rate is 5.25%. And the amount of time is 9/365 of a year. And if you crunch those numbers, notice the percentage has been converted to a decimal. That comes out to 25. So that's the interest. And then the final amount would be $2,000 plus $25.89. That would be $2,089. Next example, find the annual interest rate if a principal of $10,000 increased to $10,900 at the end of 1 year. So if we call the annual interest rate R, we know that R percent of 10,000 is the increase. And we know that the increase is 10,900 minus 10,000, which is $900. So we have to find a percentage R such that R percent of 10,000 equals 900. So just change your R percent to R over 100. R over 100 times 10,000 is going to be 100R. So 100R equals 900. That means R is 9. The annual interest rate is 9%. And that's going to do it for section 7.4.